Hello students, I want to explain in this video the trigonometry of the right triangle. The first is to define, what a right triangle is. So we have a triangle, and this triangle have one of the angles that is a right angle. So a right angle is an angle with 90 degrees. This is what we call a right triangle. Now, we know the relation between the sides of a right triangle. So if we have a triangle with sides A, B, and C, and vertex C capital here, B capital here, and A capital here, and of course those angles are also angle A is this angle over here, angle B is this angle over here, and angle C is the right angle. We know that the relation between the sides is that the square of the longest side is equal to the sum of the square of the other two sides, of the two shorter side. So we have that the longest side squared is equal to the first shorter side square plus the second shorter side square. So imagine now that you have a triangle that have the following dimensions. This side over here have 2 meters. This side over here have 3 meters. And we don't know the dimension of this side, C. So if we want to find the length of the side C, we say that C squared is equals to 2 meters squared plus 3 meters squared. So C squared will be 4 meters squared plus 3 squared is going to be 9 meters squared. So C will be the square root of 4 plus 9 is 13 meters squared. So we have now here that the length of the side C would be square root of 13 meters squared. Of course, square root of 13 is a number that you can evaluate in your calculator without any problem. So you can just find, it would be a number between 3 and 4. So 3 point something, 3.4, 3.5 maybe. Now, suppose that instead of trying to find the length of the longest side, you want to find the length of any of the other sides. So you have the triangle here. This is, of course, this was the right angle. You have C here that is going to be 10 meters. You're going to have A that is unknown. Sorry, this is B here. And this is C. So A is unknown, and we have that this side will be 3 meters. So if we want to find the length of the side A, if we know that C squared is equals to A squared plus B squared, because the square of the longest side is equal to the sum of the squares of the other two sides, solving for A squared, we get that C squared minus B squared is equal to A squared. So C squared will be 10 meters squared minus 3 meters squared equals to A squared. So, of course, in this case, we have the 10 meters squared is going to be 100 meters squared minus 3 meters squared will be 9 meters squared equal to C squared. So C will be the square root of 100 minus 9 is 91 meters squared. It also will be the square root of 91 meters. Sorry, this here, my mistake here is just meters, right? Because you already put the middle square out of the radical, so the unit of length in this case is middle. This is a square, this is now C. This is A, so this is A, right? So the length of the side A will be the square root of 91 meters squared, so it's going to be a square root of 91. If I take my calculator, for example, and I find in this case a square root of 13, that was the previous case, a square root of 13 is 3.61. So here C will be 3.61 meters. If I find, for example, the square root of 91, I can say that in this case A is equals to, let me erase this radical. So square root of 91, I'm going to say that is equal to 91 square root is 9.54. This is 9.54 meters, right? So this is how you find the length of the side of the triangle. Well, in these two examples, I just explained, how we can find the length of the side. Now, I want to explain something that maybe you didn't study deeper before. There is about the trigonometry ratios or some trigonometry functions. So, suppose we have this same triangle. And when we have this triangle, there is a triangle ABC. If this is angle A, this is angle B, and this is angle C, and we know that in this case, right, angle C is a right angle, of course. What we know that the total of angle A plus angle B plus angle C is equal to 180 degrees, right? So this is always true for the triangle. The total of the interior angles of the triangles is equal to 180 degrees. So if we have a triangle here, ABC, with this angle C, a right angle, and this angle over here, an angle of 20 degrees, and I want to find angle B, I know that angle A plus angle B plus angle C equals 180 degrees. So we have here, that angle B is equal to 180 degrees minus angle A minus angle B. So, minus angle C. So angle B would be here, 180 degrees minus, we know angle A that is 20 degrees minus we know angle C that is 90 degrees. So angle B would be 180 minus 20 is 160, 160 minus 90 would be 70 degrees. So now we know that the measure of the angle B, the interior angle B, will be 70 degrees because the total of the interior angles of a triangle is equal to 180. Okay, now we're going to discuss about the trigonometry ratios. So, as I was mentioning, suppose we have this right triangle here, with sides with angles ABC or vertex ABC, right? So there are some ratios, right, that we call trigonometry ratios. So if I want to find the measure of the angle rate, there are some ratios that I can work with, right? And I'm gonna let me find either the measure of the angle rate that is unknown or the measure of the angle B if I know the measure of or the length of the different sides. So the first is to identify that this side over here is the side that we call the opposite side to angle A, right? Because it's like the side that is in front of angle A. And this other side over here is what we call the adjacent side. And this is what we call the hypotenuse. So we know that one of the ratios is the sine. So I can say that the sine of the angle 8 is the opposite side over the hypotenuse. The cosine of the angle 8 is the adjacent side over the hypotenuse. And the tangent of the angle 8 is the opposite side over the adjacent side. Those are not the only trigonometric ratios that exist. We have other trigonometric ratios like the secant, the cosecant, and the cotangent. So there are more trigonometric ratios, but we're going to work in this case with these trigonometric ratios only. So for example, if I want to find the angle 8, so let me say that I know that this side here is 2 meters, and I know this side is 5 meters, right? And I don't know, this is a right angle, and I don't know angle A here. I can say that the sine of the angle 8 is the opposite side, that is 2 meters, over the hypotenuse, but I don't know the hypotenuse. So how do you find the hypotenuse? The hypotenuse is equal to the longest side. So you can say that the hypotenuse is c squared equals, 5 meters squared plus 2 meters squared. So C would be the square root of 25 meters squared plus 4 meters squared. If you square those, so C would be the square root of 29 meters squared. And the square root of 29 is equal to 5.39, 5.4. So I'm going to say 5.4 meters. So if I found here the C is 5.4 meters, now I am ready to find, the sine of A. Because sine of A is opposite side, there is 2 meters, over the hypotenuse that is 5.4 meters. Right? So the sine of A, if I simplify the meters out, would be 2 over 5.4, so 2 divided by 5.4, according with my calculator, 2 divided by 5.4 is 0.37 approximately. Okay, so if I want to find the angle 8, I have to use something that you learn in college algebra, that is the inverse function. And basically here to find the inverse function, what you say is this: if I apply inverse function to both sides, inverse function is sine inverse. It's like a sine to the -1. This is just really the notation of sine inverse. So if I apply sine inverse to both sides, I say sine inverse of the sine of A equal to the sine inverse of 0.37. Sine inverse of the sine of A will be A. So A will be equal to the sine inverse of 0.37. So if I find, the sine inverse, let me see where is my inverse function here. The sine inverse here is of 0.37. That is equal to 21.71 degrees. So 21.7 degrees. So I found there, the sine. That means the value of the angle. So I found the sine of the angle. The sine of A is 0.37, 0.37. And once I know, the sine of the angle, I can find the angle just by using the inverse function. Exactly, as I found there, this sine of the angle, I can find the cosine of the angle. So the cosine of A here would be, in this case, adjacent over hypotenuse, right? So the adjacent, we know that is 5 meters over the hypotenuse, that is 5.4 meters, right? So we can say that cosine of A, we simplify the meters out. So cosine of A is 5 divided by 5.4. So that would be 0.925. That means 0.925. So if I find A here using the inverse function, would be cosine inverse of 0.925. And I have to get exactly the same angle, right? Because you have the same angle regardless of what function you use to find that angle. So if I say here now cosine inverse, I turn off my calculator. If I say cosine inverse of 0.925, of course I am rounding, so there would be a very, very low difference, because I am rounding here, because this number really was 0.37037, so it was like 0.370 period 370, and this one is really, 0.925925, so it was 0.925 period 925, right? So there is a little difference, between the number that I use here, 0.37, 0.925, like this. So they say that this is like a 22.3 degree. But the difference that we have between these two values is basically because I was rounding these values, but you should have exactly the same value, if you don't round. I mean, see, if I use just the quotient and I say, for example, cosine of A is equal to the cosine inverse of the quotient of 5 divided by 5.4, that would be the same value. I can find also the tangent, and I know that tangent of the angle rate is opposite side over adjacent side. I know that the opposite side, as you see here, the opposite side was 2 meters, so tangent would be 2 meters divided by 5 meters. So it would be the tangent inverse. I am going to simplify the meters, but I'm going to leave it at that. So 2 over 5, well, 2 over 5 is very easy to find, 2 over 5 is 0.4. So this is because tangent of A, when you find 2 over 5 here, this is 0.4. So when you find the tangent inverse, the tangent inverse, sorry, you get tangent inverse of 0.4. So you say equals the tangent inverse of 0.4. So let me say in my calculator, tangent inverse of 0.4, that would be 21.8 degree, So you see very close to this value, and of course also very close to this one. So the rounding here was what made a difference, So these are the trigonometry ratios that we know. And now in the next video, we're going to see how we apply these trigonometry ratios in order to find the projection of a vector on the x and y axis. That means the components of a vector on the x-axis and on the y-axis. So I invite you to watch the next video.